I'm also delighted to be in Australia. This is my first visit, and friends have told me how wonderful it is, and I wasn't quite sure if they were telling me the truth, but now, having seen Sydney for 4 days, I'm very impressed. And tomorrow I'm going to Perth, and I suspect I'll be impressed there too. The first two slides are about climate change, and one of the two reasons that I'm really eager to share what I have learned and what I think is going on. The other, of course, is that I love to travel, so having an excuse. But talking about climate change actually makes me feel better if I can have some small impact to prevent the worst that can happen. And I found this slide many years ago, and it has converted numerous people who were deniers, and obviously this is excellent proof. It's just so strange that there are people who still deny climate change, although that's dropping. In the United States, about half Republicans are now accepting that climate change is a reality. So it's slowly changing, but there's lots of evidence. I don't want to make this discussion about climate change, but I want to make a very important point of how serious it is. And of the many consequences, one of them is going to be the rise of sea levels. Okay? And so the question is, how much is sea levels going to rise? The latest estimate by scientists is maybe somewhere between 1 and 5 meters by the end of the century. We really don't know because this is all new experience. We haven't had climate change as something we can draw on in our experience. So it could be much worse, maybe less severe. But one thing we know as a fact is, what is the worst case? Suppose all the ice on Greenland and Antarctica melts. And that has happened in geologic time. It's not impossible. And we're on a trend for that. Ice is melting in both places. And we know how much ice there is. We know how deep it is. We know the area. It's a simple calculation to figure out how much the oceans will rise or would rise if all the ice melts. And I'm not saying it will happen, but it could happen. And we really have to act to prevent the worst from happening. So I'm trying to show you what the worst is. Does anybody know what that number is? How high will sea levels rise if all the ice melts?
Taking a guess, 30 meters.
Well, that's actually a very good guess. But the answer is 80 meters, okay? Now, that is if all the ice melts. What we basically have to do is prevent the worst from happening. And the National Geographic last year had an article showing maps of different parts of the world, indicating how much of the Earth, the landmass, would be flooded if the oceans rose that much. And you can see here what would happen in part of Europe. Bangladesh would disappear. The ocean would move 500 miles inland in China, flooding the most fertile land. It would be an absolute catastrophe. This is a map I found on internet of what would happen in Melbourne. And you can see that we're talking about somewhere around here, 80 meters. So all of the area that is colored would be submerged. I also found an article about Sydney, which I thought would be more interesting for you. This is not a very sharp image, but it's the best I could find. I tried to track down the origin. It even tells you on here, but whenever I went to the site where this map supposedly came from, I did not get access to it. So I just want to explain why I'm showing you such a poor slide. But nevertheless, you can see on here that 80 meters would be around here, so all of the green would be underwater. I take this as a critical time in humanity, and we have to do everything possible to prevent the worst from happening. So there are hundreds of things we can do, and since we have very limited time, I thought I would talk about two of the strategies that are available. And that one is the orientation of buildings, which is very much related to the orientation of streets, and also the color of buildings and color of cities. To me, knowing about the tremendous advantage of orientation, for example, a building before it's built, say, if you designed it to be arranged in the worst orientation, and then you recognize that it would be better to rotate it and build it with a better orientation, you could save up to about 40% of the energy required for heating, cooling, and lighting at no cost. Now, of course, in central cities, you don't have that flexibility, but the advantage of the correct orientation is gigantic, and yet it is little used even when the potential is there. So the advantage of orienting streets to run east-west so that buildings face north and south is not a new idea. The ancient Greeks, 2,500 years ago, when they laid out new cities, several of them were arranged to give them the best orientation. And yet, maybe when the Dark Ages came, they just totally obliterated all this knowledge, and today it's still rarely utilized. Here's a tree of solar fruit, and one of the principles that everybody agrees on, I think, is that you should pick the low-hanging fruit first. Do those things that are inexpensive and easy before you do the things that are difficult and hard. And yet, most interest by the general public and many professionals is on the highest fruit, the photovoltaics, while the lowest fruit, which is free when you have the opportunity to do that, is rarely picked. I keep running across buildings that had the opportunity to be oriented correctly, but they were not. I keep finding developments that are laid out without taking advantage of this. Before I show you an example of a development, having the correct orientation means that many other solar strategies become a practical application. Without the correct orientation, you find that it's very difficult to have passive solar, to have effective shading. Daylighting is very difficult. So these all depend on the orientation of the building for maximizing their effectiveness. One of the reasons that orientation is so little used, even when it's available, is that it's to really appreciate that, you need to understand solar geometry. And it turns out solar geometry is quite complicated. And most people really, even though they experience the sun every day, they really don't know how to design a building or a community to take advantage of solar geometry. Here's a kind of a condensation of the situation. In the summer, the sun spends the whole morning in the eastern sky and the whole afternoon in the western sky. And so east and west windows are problematic. They get the most sun in the summer. This is everywhere on the planet, whether you're in the northern hemisphere, the southern hemisphere, or in the tropics. So the best solution for a building is to minimize east and west windows everywhere on the planet. If the building is oriented correctly, then that becomes an easy thing to accomplish. The north and south, depending on which hemisphere you're on, are the desirable orientation. They can collect winter sun, and they can be easily shaded from the summer sun. I have found a few examples around the world of cities that are oriented correctly, but there are very few. This is a city in China, and I don't know if it's a coincidence, but this is a city, it's called Daeju. It is actually where many of the solar collector companies have their headquarters and their factories. But you can see that the city is laid out with the streets running east-west. And so the buildings have, except for the very end, all the buildings have only windows facing north or south. They don't have any of the problematic windows facing east and west. The result is that these buildings will use at least 10% less energy for heating, cooling, lighting, and potentially as much as 40% less at no cost. And the key thing is laying out the streets correctly to make this, to allow these buildings to really perform well. One of the other developments that recognizes the advantage of this is in Germany, in Freiburg. There's a new development called Vauban, and these are actually energy plus houses. And one of the reasons is the large photovoltaic array on the roof, but if the buildings weren't oriented correctly, they could not produce enough energy so that they would actually produce a surplus. Okay? So this community is a energy plus, better than zero energy, because the buildings are oriented correctly. Without orienting the buildings correctly, you cannot get the energy consumption down to the point where you have enough roof area to produce the electricity needed. And certainly, that's an expensive aspect of solar design, while the orientation is free when it's available. This is one of the other communities. It's called Village Homes. It's in Davis, California, which is a suburb of Sacramento. This development was built about 30 years ago. It got a fair amount of publicity. I learned about it. I went to visit it. It's just the most delightful community. There are 200 houses on a north-south parcel of land, and they are all oriented correctly because all the houses are on east-west cul-de-sacs. This development is a great success. The houses there are very energy efficient. They consume much less than a normal development. It's a very delightful development. They're just, and not more expensive. And the tragedy is, it has never been copied, at least not to my knowledge. And every time I fly in and out of a city and see new developments, none of them are taking advantage of this knowledge that was proven to work 30 years ago. And so I see the lack of understanding or the lack of interest. I'm not sure what the problem is. I see it as a kind of a tragedy, because these communities would use a lot less energy, would be much less harmful to the environment. And of course, hopefully you realize, and we're thinking, well, not all the houses can be on east-west streets. Some have to be on north-south. But if you lay out the blocks so that they are long in the east-west direction and short in the north-south, you minimize the number of buildings with the difficult orientation. And there are also examples of how you can still have windows facing east and you can have windows on east and west walls without facing east and west. I've invented two of these heliodons. Heliodons are devices that simulate sun angles so that you can study how a design will work. In schools, these heliodons are used to teach solar geometry and solar strategies. I think that if every planning department or every school had a heliodon, they would see for themselves how, for example, the advantage of orientation, or how some shading strategies don't work. There are a lot of myths about what is the proper thing to do. So I make no money with the Heliodon, so this is not a commercial. I'm trying to make money. But I think that's one tool that can help people see, to help the clients see what an advantage. Because people find it hard to believe that you can get something for nothing. And orientation is a free lunch. Actually, it's even better than that. A house oriented correctly will have a smaller air conditioning system than one incorrectly, so it actually costs less to build a house with the correct orientation. Initially, costs less, and it costs less for the life of the building. It's just unbelievable. The Heliodon shows very clearly, within 5 minutes, you can see the logic. If you don't believe what I'm saying, the Heliodon is the way to see it for yourself and to convince others that this is really a strategy to save energy and to save the planet. Now, the laying out of the streets, of course, is limited to new developments, but all over the world, cities are being built, new developments are being built, and the longer we put off taking advantage of this strategy, the more of an opportunity we lose. I also, you can use orientation within the existing grid, but you're more limited in what you can do. For example, you can have few east and west windows and more south and north, even if the building is not oriented ideally. The second topic I want to talk about is the free lunch. Again, it's free to use color to reduce the energy consumption and therefore the impact on the planet. The physics is, and ASHRAE, for example, tells you that the heat gain through a white roof is half of the heat gain through a black roof. And how much more expensive is a white roof than a black roof? Well, in most cases, when you're designing and building a new building, there's no difference in cost. It's just a matter of specifying. So you can reduce the heat gain through the roof by 50% without spending any money. The heat gain through a wall can be reduced a third just by going from a dark color to a light color. Our previous Secretary of Energy, Stephen Chu, he was, I think last year or 2 years ago, he left as secretary, but he was under Obama. And one of the statements he made, you can see on the right, is that using light colors, especially for roofs or other surfaces, like streets and sidewalks, using maybe concrete instead of asphalt for streets, can make a significant difference in the rate that we're heating the earth. What we want to do is take the solar radiation and reflect it back into space. Right now, with dark colors, the solar radiation is coming in and gets absorbed. It heats up the buildings, so you need more air conditioning. It also heats up the environment. So one of the reasons we have a heat island effect for cities is that the cities absorb an excess amount of solar radiation. So it's not just individual buildings that are being affected, it's the whole city. And as the buildings, as the city gets warmer and the buildings have a greater heat load, they run the air conditioning more, dumping more heat into the city, requiring more air conditioning. So it's kind of a vicious cycle. Reflecting the radiation. In the summer, you don't need that radiation. Reflecting it back into space is the ideal solution. And there's in hot climates, it's a tradition. In the American South, the walls were frequently a light color, white, although the roofs were not. And that is one of the questions that we might address later in the panel. And here's the Raffles Hotel in Singapore. This, of course, where rich imperialists lived without air conditioning in a very hot climate. And so they had to use all the strategies that were available. And what's a major strategy other than orientation is the color. Okay. Casablanca, I went to visit that some years ago, and basically means white city. Okay. Whenever I suggest using lots of white in cities for walls and other surfaces, the immediate reaction is, oh, it's going to be glary. Well, I was in Casablanca and I didn't have any problem with glare. What happens is if the city is mostly dark and you have one white building, your pupil is opened up because of the general dark environment, and then that white building is a source of glare. But if everything is white, your pupil shuts down and it is not a major source of glare. And it has major benefits for the environment. White buildings will need less air conditioning, they will need smaller air conditioning plants, and they will use less energy over the life of the building. So here's another free lunch that you get paid to eat, as Amory Lovins has said. The building is less expensive to build, and it saves you money forever after. Why doesn't everybody take advantage of this? Many business-minded people say, yeah, you know, maybe the environment is in danger, but it's too expensive to do anything about it. Well, here we see you can actually save money by saving the environment. This is the National Library in Singapore, and it has many strategies. It shades windows, it has light shelves to collect daylight, and it's got white surfaces to reflect the light back into space. I'd like you to remember one thing, that white is the greenest color. There is one exception, and I'll show you that in a moment. Okay? And I'm just repeating here what I said before. The basic strategy is to reflect the radiation back into space when in hot climates or in the summer. When I suggest that surfaces should be white, you might think, well, as opposed to dark surfaces. But actually, even worse than dark surfaces are reflective surfaces. Glass is the fashion today. All glass facades are becoming ever more numerous. They are really not very helpful to the environment for many reasons. Glass is a poor insulator. But what I want to emphasize here is that the glass acts very much like a mirror, and actually, instead of sending the radiation back into space, it's reflecting it down to the street level, heating that area, making it less comfortable for pedestrians, heating the air of the city, raising the heat island effect, and so the buildings will have an additional load because of the city getting hotter. Instead of that, we want to reflect the light back into space. And 2 days ago, I was walking around in Sydney, and when it's hot, I always try to walk in the shade. And I thought I was walking in the shade. All of a sudden, I was in the sun, even though I should have been in the shade. And it was the reflection from one of these glass buildings. So here's white is the greenest color. The only alternative to that would be vegetation. Right? And vegetation has advantages that can compete with a white surface. White is probably less expensive, but vegetation has other benefits. And from a climate change point of view, I think it's probably just as effective as white, but it also has benefits in terms of biophilia, that it makes a city a more humane place. One of the challenges is that suburbia, by its very nature, requiring commuting and individual buildings, is very energy intensive. How do we bring people back into dense urban areas to reduce the energy consumption? Well, one of the reasons people move to the suburbs is for the greenery, for the vegetation. If we made cities more green, having more plant life, it would make cities more attractive, and maybe more people would be willing to move back into cities. This is a school in Bangkok. I wish my school had looked like that. So here are two strategies that I think both would be significant if they were applied.